Hey folks, Mr. Dell here. We're going to do a little geometry. I'm taking this problem from CPM Course 2, Section 6.2.3. So let's read what it says. Using the information from the parallelogram shown at the right, here's my parallelogram, redraw it with sides that are half as long. So I'm going to first create a similar parallelogram, but specifically with sides that are half as long, right? So if I redraw this, and I'm going to do it over here next to it, it's going to be smaller because it's going to be, each side is going to be half. So I'm going to approximate what this one looks like, right? So if I look at the top one, that's 6 units. Half of 6 is 3. So this would be 3 units on top. Okay. And if I look at the side of the parallelogram, that is 2.5. So a little trickier, 2.5, half of 2.5. Think about if you're not a big fan of division, right, and you are having to deal with decimals, think 2.5 is $2.50, right? Half of that is what? $1.25, right? Think about it that way. So it's $1.25 is half. So 2.5 divided by 2 is 1.25. So here's my side lengths. What do we also know? Keep in mind, right, if it's a parallelogram, then opposite sides are equal. So this side here is 6, this side here is 2.5, and then the same thing's true with the new one, right? This side here is 1.25, and this side here is 3. So that way we've got all of the sides labeled. So first thing, it says find the perimeters of both the original and smaller parallelograms. Okay, so perimeter of original, say perimeter P of original is equal to, so the perimeter would be adding the sides, would be 2.5 plus 6 plus 2.5 plus 6, right? So when I do my math, I'll add those decimals together. That's 5. And then the numbers here is 12. 6 and 6 is 12. So 5 and 12 is 17. So it's 17 units. There's the perimeter of the original. The perimeter of the new, the smaller one, we add the sides. Again, 3 plus 1.25 plus 3 plus 1.25. What do we get there? Well, I know the 1.25 plus the 1.25 is 2.5 because that was the half that we took. So now it's 3 and 3 is 6. So 6 and 2.5 is 8.5 units. Okay. And if we think about what we just did, if I found the perimeter at 17, what's true? Because all the sides are half, the perimeter should be half. So let's double check. Did we do our math right? Half of 17 is 8.5. So yes. So that does make sense. B, it says if the height of the original parallelogram drawn to the side is 6 units, and the drawn to the side of the 6 is 2 units. So the height. So let me explain what they're saying. The height. Remember, height has to go from the top of it to the base and create this 90 degrees. So that's the height from the top to the bottom, from base to base, okay, with a length in this case of 2. So that from there to there is 2 is what they're saying. That's the height. The height is important because in order to find the area, you need the height. Area of a parallelogram. So area of any parallelogram is always the base times the height. Okay. So if I want to find the area of both parallelograms, again, the area of the original base, which is 6 in this case, times the height, which is 2. So it's 12, and we'd say units squared. How do I find the area of the new or the smaller one? Well, what's true, go back up to it, draw it with sides that are half as long. So if the height was 2 on the original, the height on the new is going to be 1, half of 2, right? Half of 2. So the smaller, we have the base is 3 times the height is 1. So 3 times 1 is 3. So the area of the smaller one is 3 units squared. Okay. There we go.